Included in the Chic TV kit are our two 3D printed pieces, one push rod, one linkage stopper, 6 nuts, 8 washers, 4 8mm M3 screws, two 10mm M3 screws, and two 12mm M3 screws. Needed to complete our kit is a Phillips screwdriver, a needle nose plier, something to cut the push rod with, a 3mm Allen wrench, a 1.5mm Allen wrench, an MG90 9-gram Metal Gear servo, any brand of your choice. You'll need the control horn, the screw for it, and you'll also need a mounting screw. For electronics, you're going to need to get a 6-channel receiver for the aeroscout, and of course, the aeroscout. Alright, to kick off the start of this thrust vectoring, we're going to start at the base, as of where all strong things start. We're also going to need 4 of the 6 included lock nuts. These lock nuts are going to be placed in these 4 slots right here. For this process, pliers are your friend. And just like this, just slots right in there. For the next step, grab an MG90 9-gram Metal Gear servo and one of its mounting screws. There'll be a link for this one in the description, but keep in mind that this does not come with the Chic TV kit. Now we're going to slide the servo into the base. We're going to do it at this orientation, allowing the wire to slide through this opening right here. What I like to do is I like to grab the servo by the tip just like this. I slide it through and I pull. And now once it's like this, we can just pop it in like this. Make sure that the wire is exposed here and that it is not catching on anything else. Now you're going to take a mounting screw and you're going to place it at the top right here. Do not place another one at the bottom, for the wire is directly below it and the screw will break it. So now we can set this aside and get the aeroscout ready. So the first step for getting the aeroscout ready, grab your 3mm Allen wrench, and right there in this hole there are 4 8mm long M3 screws. Unscrew them, allowing the motor to release. After that process, you should have a dangling motor, and you should have 4 8mm long M3 screws. 2 of these you can keep for extra, and 2 of these we will use for the assembly. For the thrust vectoring, you need extra wire here. So I would like to show you a technique that I developed called pull until something happens. There we go, something happened. We now have extra wire here, allowing us to go up and down without any of the wires unplugging, because that's just a bad day. So grab the included thrust vectoring motor mount, along with 4 8mm long M3 screws with 4 washers. Start us off, we're going to place the 8mm long M3 screws through these 4 holes just like this. Once this step is complete, take any finger of choice, place it over the screws, and flip it around just like this. Now with the 4 washers, place one over each screw. This will make a gap between the motor and the motor mount. This will allow for better cooling from our air ducts right here and better airflow under the motor so that it can give our part a longer lifespan, and it will keep the motor from overheating during aggressive flying. There will be a gap right here where the wires will just slot into, and you'll just slide the motor onto all the screws at once like this. Now you'll be able to take your 3mm Allen wrench and tighten them down. We now have 2 completed parts. We have the base and we have the motor mount. This is the orientation it will be in. With that knowledge, let's combine them. For this step, you're going to need your 12mm long M3 screws, and you're going to need the remaining 4 washers, and also 2 lock nuts, the remaining 2 lock nuts. First, you're going to place a washer over a 12mm long M3 screw. You're going to then place it, ignore that, through this hole, so that the washer, there's a washer here. Now you're going to grab another washer, place it over. We'll grab our thrust vectoring base, slide it through just like this. Now you grab a lock nut, and keeping tension on it, you can just start by hand tightening it on like so. Here's another view. You can see that the bolt is right through here in its slot. You have a spacer here and a spacer here. This will be the orientation of the part. You can now flip it over to the other side, and it should be noted, it doesn't matter which side you put the bolt in first. I just chose this side. Either way, it's going to be the same process. You're going to take your last 12mm bolt, put a washer on it, slide it directly through the hole just to hold it for now. You're going to grab your last washer. You're going to back out. We have to put the washer in that little gap right there. You're going to back out the screw just a little bit. And you are able to bend the part a tad, but don't overdo it because you'll break it. And just as so, you can put the screw through the washer. Just like that, it's through the side. Now you could grab the last lock nut. And just as so, as previous, you can start by hand tightening it. Then you can grab your 3mm Allen wrench and start tightening it. Now keep it loose because this will be a moving part, and we will get to that tightening process later. Let's get it ready for mounting. This ESC wire is going to go through this slot as well as the servo wire. Same as the ESC wire, again, you'll thread it right back through here. Give it a good tug. And you'll be able to thread it right under the supports for the wing bolt hole. Now grab the 8mm long M3 screws that you got from undoing the motor. And the last screws that are included in our kit, which are the 10mm long M3 screws. Both the 10mm M3 screws will be placed on the right, and the two 8mm M3 screws will be placed on the left. Make sure when you are putting the thrust vectoring mount onto the aeroscout that the wires are not getting caught or underneath this, but they are rather going right through into the fuselage. We first have to center the servo. I'm going to be using a servo tester, but if you do not have a servo tester, plugging this into the receiver and turning it on will center the servo for you that way too. Now with the servo centered, place the control horn onto the servo in a way that it's the most vertical downward. You can now take our included push rod, and this is the important step. Do not put it in this way. You want to put it in from behind, so there's no curve or bend to the servo rod connecting to the linkage stopper hole. Just like this. We can now take our linkage stopper and a 1.5mm Allen wrench, and you can back out that scrub screw just a bit so that you can fit it onto the push rod, as so. Now you'll just undo the linkage stopper, take a washer out. You'll be able to put it directly through like this. Once it is in a central position, you can just eyeball it. You can tighten it up so that the linkage stopper and everything will stay in place, just as so. You can now screw in your servo horn and cut off the access wire. If we flip this upside down, you can put your remaining washer and nut onto the linkage stopper. After you hand tighten that on, I come back with some pliers and just make sure that it is all tight enough. Last part is getting these bolts to the right tension. You want to adjust the right tension, that there's just a little slot, and your servo will move freely. First, we'll have to replace the stock receiver with a 6-channel receiver. Once we have a 6-channel receiver in place and bound up to a radio, you can then plug in the thrust vectoring into channel 5. Alright, we're getting technologically advanced here. This is the radio I use. Any radio above 4 channels will work. This is how I set up the thrust vectoring. I go into the function list. Then I scroll down to system setup. Next, I go to channel assign. I then make sure that channel 5, which is what the thrust vectoring is plugged into in the receiver, that there's no switch assigned to it, which there is not. Next, I can go completely out of system setup, back into function list, and we will go to mixing. And mixing, we'll start one in mix 1, and I do elevator to gear, and this is where personal preference matters here, is rates. I do 125 to 125, and you may have to offset, so if I mess with this, just to adjust it, just to get straight. If it's a little off, I mean, I always just eyeball it, and it works just fine. Then I have it set up on a switch. So when I flick the switch, I just have elevator. When I flick it again, I have both combined. Next, my servos, all my travels are at 150. And for DR and Expo, my Expo is always at 20% on everything. And my rates go in exponentials of 25. So I go 50-20, 75-20, and 120 on all my settings. And that is what I use to fly the Chic TV on the aeroscout. Reminder, the links for the receiver, servos, and the Chic TV are in the description. Take a look at our website. We also have an aeroscout nacelle EDF conversion kit.